Hello everyone. Welcome to the second part of Flowcharts. Yesterday you've learned about sequential structures and decision structures. Oh, you don't know what it is? Don't worry. Sequential structure for a flowchart is the structure where you start, you input something, then you are going to process it, you display the result, and you stop. So notice sequential is for a reason. You do this, and that, you are done. Okay. So yesterday we were adding, I believe, two numbers and using the sequential structure. Now, then there's the decision structure. We've done it as well. How? Well, we input something and then we evaluate it. And based on this evaluation, we go one way or we go the other way. We cannot go both at the same time. If we did, it would be just a sequential structure. So we go this way and we stop or we go that way. Today we are going to learn loops, and that's the second page of this handout. You've got it in your folder. So let's go back to our sequential structure though. All right, why? Well, sometimes we don't have just two numbers to add. We might have more work to do. For example, create a flowchart that does the following. Three numbers are input. The first two numbers are added, then the sum is multiplied by the third number, and then the final result is displayed. Still sequential. Now let's watch. So do we start with what? With an oval. Start. Then the next thing is we input three numbers. The shape is, of course, parallelogram, and we are going to name them N1, N2, and N3. Okay, the next step. The first two numbers are added. Okay, that's processing or action, which means we have to use an action or processing shape, which is a rectangle. And what are we going to obtain? We are going to add two numbers. Well, that means we are obtaining a third number. It's a good idea to call it what it is, which is a sum. So let's call it a sum. Sum is equal to N1 plus N2. All right. Now, the next one. The sum then is multiplied by the third number. Wow. Again, it's the same shape, which is the action shape, but the variable is different. Okay, the code name for the final result could be an answer, could be a result, could be a product, could be a final result. You are the boss. I will use, how about its multiplication? I'll use the name product. So, product is equal to what? Sum, that I already calculated, and multiplied by the third number, which is N3. That's it? Not exactly. Now we have to display the final result. What's the shape? Of course, parallelogram again, input and output both. Now, the next thing is, are we going to call it final result? No, we didn't calculate final result. What did we calculate? We calculated product. So we have to display product. And that's it. That's all. Now we're going to say stop. Yay! So another sequential one. Input the numbers, do something to them, do some more to them, then display the final part, which we calculated, and then stop. Our first flowchart for today. Now, let's look at the second flowchart. Oh, this one is going to be a decision. But wait, in our example here, we've got only one question, one decision. Okay, here we need to put more. So how do we do it? Well, create a flowchart that does the following. First, input mark. If the mark is greater than 70, okay, if it's equal or greater than 70, print doing well. So display doing well. If the mark is greater than or equal to 50, well, say study more. And of course, if it is less than 50, we'll say not good. How do we do it? Well, let's start. Well, guess what? Let's start. Nice little oval. And, well, we have to input the mark. Input. And what are we going to input? That's our variable. That's the name. We don't know what mark you have. Okay, we don't know what other people have. So it has to be a code name for whatever mark will be entered. The next step, we are going to ask the first question. If mark is greater than or equal what? 70. All right, if this is true, what are we displaying? Yay! Display doing well. All right. And then, if it's not true, if this is false, we have to ask another question. Remember, the question has to be logical. For example, can I ask a question if mark is greater than or equal to, well, in this case, it will work. If it's greater than or equal to 50, true. But could I say if it is less than 70? No. Okay. If you said, if you ask if it is less than 70, well, we couldn't figure out if someone was, well, at 69 or at 20. Okay. So here we've got display, study more. And finally, now, do we need to ask another question? We've got three questions here, three answers here. How many questions? Well, don't worry. We always ask one less questions than the answer. How come? Because the final answer is obvious. If you are not greater than 70, if you are not greater than 50, well, what's left? Only whatever is below 50. So an obvious answer, we are going to display. And what's going to be? Not good. All right. And after we've done all of that, we are going to say stop. Is it finished? No. Watch here. In, where's out? In, where's out? All right, so let's do it. Once we display well, okay, you are doing well, then we stop. Notice the arrow again connects to another arrow, not to the stop shape. The stop shape only gets one arrow in. All right, and we have to connect this one too, and we just connect to the existing one. We've done it. So it doesn't matter how many questions we need to ask. We just put them this way or put them that way, whichever works for you. It worked for me this way pretty well. Okay, and let's go for the next one. Oh, this is going to be a loop. Yeah, that's the loop, the repetition structure. When we do something and we repeat and we repeat and we repeat till the question becomes false and then we come out. So let's look at the example. In our example, create a flowchart that does the following. A sentence is input, a number is input, and the sentence is displayed that number of times. All right, let's go for it. Let's start. All right, and let's do the inputs. We're going to call this sentence, well, string. We could have called it as sentence as the code name, because remember, you can enter your own sentence, I can enter my own sentence, and the programs still should work. So string, less characters than in the word sentence. And we're going to have a number. Num sounds good. All right. Now, because it is a loop, we need a counter. Remember, right here, let me go back to this one, because we are repeating, we need to have a counter that will count how many times we actually did the repeating. So we are going to start our counter. Yeah, it's a rectangle shape because we have an equal sign. So counter is equal to, okay, you can start with 0, you can start with 1. I prefer 1 because we are going to display our sentence the first time. So let's go for it. 1. Now we've got a question. The question is about the counter. Okay, remember, we are going to repeat it till we can get out of the question. So it has to be about the counter. If counter is less than or equal to what? To number. Remember, this is the number of times we are supposed to show this sentence. Okay, so that's why we start with 1 the first time, and we end with the number, well, whatever number we enter. And if this is true, watch this. We display string. And then we want to get out of this loop, so we have to make sure that our counter is up. Counter plus 1. All right, so the string and the number, the counter starts with 1. As long as the counter is less than the number, display the string and add 1. And how are we looping it? Look at the line right there, and going back right here. So we'll be going till finally this question becomes false and it becomes stop. Now, you don't see it yet, do you? Well, in case of loops, it's a good idea to have a trace table. How does it work? In a trace table, we actually put the important things in, and then we will go through the program to see how it works. Okay, so I'll start with a counter here, and then with a string here. Okay, so let's go through the program. String. Okay, let's say that our string is high. You know, I don't want to write too much. Okay, and let's say that now a number, okay, let's not make it too big, is 5. Okay, so what we want to say, what we are saying, that the high should be displayed 5 times. Can we check if it works? Sure. So let's go. We've done this. Now the counter starts with 1. Okay, 1. Is 1 less than 5? See, is counter less than number? Is 1 less than 5? Sure it is. So what are we supposed to do? Display the string. Okay, let's do it. Then the counter becomes 1 plus 1 is 2. Ta-da! All right. And with the 2, we're coming right here. Is 2 less than 5? Sure it is. Display high. And counter becomes 3. Is 3 less than 5? Sure it is. All right. And the counter becomes 4. And again, with 4, is 4 less than or equal to 5? Sure it is. High again, and then it becomes 5. 5? 5. Oh, wait. Let's look at the question. If the counter is less than or equal to 5, all right, so 5 is equal to 5. Display the string. All right, and then the counter becomes 6. And with 6, is 6 less than or equal to 5? No. Stop. All right, look at the trace table. How many highs do we see? 1, 2, 3, 4, 5. Yay! That's it. That's all. All right, so let's do another loop. Now, this is a little bit different because we will be dealing with only numbers. So, create a flowchart that does the following. Input 2 numbers and add all numbers between those two, including those 2 numbers. Then display the sum. So, for example, if someone enters 1,000,000 and 2 million. Okay, computer will add 1 million plus 1 million and 1, 1 million and 2, plus 1, 1 million and 3, etc., 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 till it comes to 1,919,000. Oh, well, you know what I mean, okay? And 2 million. We are not going to do it in our heads, no way. We are going to choose some smaller numbers for our trace table. But before we do the trace table, we have to do the flow chart. So let's start. Let's start with start again. And input two numbers. Here it is, same shape, input shape, and we've got N1 and N2. Now, add, oh, wait just a second. How are we going to add it? Now, we know we have to add it, so there will be a sum. There will be a variable called sum. Let's start with that sum. Because we are going to have an equal sign here, we are going to have this shape, action or process. How come? We will assign a number to sum, 0. This to make sure that there's nothing inside of the variable called sum. The next one, again, because we know it is a loop, we need to have a counter. Okay, and we'll initialize the counter. So counter is equal to, now remember in our previous example, our counter was 1. We are not going to use it. Before we used 1 because we're displaying the first time. Now, this time we have to start counting from 2. Now, from 2. If we have 1,000,000 and 2,000,000, we need to start counting with the million. So it will be million plus million and 1 plus million and 2. All right. So what will be the starting number for the counter? And 1, our first number. Now we are going to ask the question. Again, the question is about the counter because the question will keep us going or kick us out from the loop. So if counter is less than or equal to what? Well, to the other number. So from million to 2,000,000, starting with 1,000,000, going to 2,000,000, for example. Now, if this is true, all right, what we are supposed to do? Create that sum. Sum will be our dumping thingy. Oh, that's called accumulator. So watch what it does. Sum is equal, the new sum is equal to the old sum plus counter. And then the next step, another processing shape or action shape, counter is equal to counter plus 1. And that's what our loop is. All right. Now, so we entered two numbers. We made sure that the sum is clean. We've got the counter that starts at the first number. We've got the counter that ends. And while it's still, the counter is less than the second number, what do? We dump to the sum. Every time we go, we dump a new number. And then we get the counter up by 1 every time we loop. Now, what's missing? Display the sum. When we are going to display the sum? When we finish counting. So here it is. If it's false, we finished our counting. We just display our sum. All right. And that's it. And stop. A bit confusing, isn't it? Don't worry. We will use our trace table to see how it works. So here's our trace table. And here we are going to start, well, let me see what would be the better one. Sum, we'll start with a sum, and then counter will be right here. Okay, which is kind of logical. We put the sum first, counter, then sum and counter. Okay, so as we go through, as we go through the program, will be updated each. Now, so first we have to start with those two numbers. No, 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 no. There will be no million. There will be no 2 million. We'll leave it to the computer. Now, I'm going to go with something smaller. For example, I'm going to go with n1 that is equal to 4 and n2 that is equal to 7. Much less calculating. Okay, so let's start. We've got this n1 and n2, 4 and 7. Our sum is 0. Okay, we better write it down. And our counter is our first number. What's our first number? 4. Let's go for it. All right. Now, let's continue. If counter is less than the second number, so is 4 less than 7? 4, that's our counter. Is it less than 7? Yes, it is. What are we supposed to do to the sum? It says the new sum is equal to the old sum plus counter. Our old sum was 0, counter is 4. Well, here it is. We've got our first new sum. And then what happens to the counter? Well, it becomes 5. All right. And we continue with 5. Is 5 less than 7? Sure it is. So what sum? Our new sum is equal to the old sum plus the counter. Our old sum was 4. Our counter is 5. 4 plus 5 is 9. All right. And then what happens to the counter? Well, we add 1 to the counter. There was 5. Now it's 6. Now let's go here. Is 6 less than or equal to 7? Sure it is. So let's go for the new sum. Our new sum is equal to the old plus counter. So 9 plus 6, guess what? The whole 15. All right. And now, what happened to the counter? Now it becomes 7. And we continue. Oh, 7. Watch this. Is 7 less than or equal to 7? Well, 7 is equal to 7, so it's still true. So our new sum is equal to the old sum and the counter. 15 and 7 is 22. All right. And then our counter becomes 8. 7 plus 1 is 8. Let's go. So is 8 less or equal to 7? No, which means we come out, and whatever we had in sum, that's exactly what we are going to display. Not this, not this, not this, not this. The last value in the sum will be displayed. And if you want to have a calculator, you can easily calculate or just look at those numbers, 4, 5, 6, and 7. 6 and 4 is, of course, 10. 10 and 7 is 17, and add 5, well, guess what, is 22. We've done it. I wanted to show you, though, one other thing, very interesting thing. What if, instead of sum, we would have the word display the product? Okay, how could we change this PowerPoint very easily? Watch this. What if instead of adding, we want to multiply? What changes would we need to this PowerPoint? First one, of course, it wouldn't be sum. It would be a product. Would we start with 0? So let's say if the first number is 3, it will be 3 times 0, 0 times 4 is 0. No, it won't work. So if we want to multiply all the numbers between, let's say, 3 and 5, we have to start not with 0, because we are multiplying, but we are going to start with 1. So instead of sum equals 0, we are going to have product equals 1. This will be the same. This will be the same. Here, we are going to change the whole inside of the box. We are going to see product is equal to product times counter. And of course, the counter stays the same. See this? Instead of adding the counter, here we are multiplying by the counter. And then instead of display sum, would have display product. And we are done. This is it for today. Have fun. Work on that assignment. You will need to do it using Word or shapes in Google Docs. You'll need to drop it off, and I'm going to mark it. Enjoy.